All right, so I'm going to just walk you through a couple of the examples and the problems in your homework so then you can go and work on the next few doing the same kind of thing we do. So the first thing is when we have these, we're trying to write the line of best fit. We're going to do this with a lot of different families of functions, so we really want to use Desmos. So the first thing I'm always going to do is insert a table. So then, just making this a little bit smaller, and I'm going to pull up my smartboard. And so I can do this, you can do this on your computer as well, so just so you can see all of your data and type it all in. So I see that my x values, right, we're just going to type in the points that we have. So then 13 and 5 and 18 and 22, whoop, 18 and 7, and then 22 and 10, and then 23 and 11. So now that I have this data in Desmos, I can go ahead and I just always want to look at it and see what it kind of looks like. So if I scroll out, I see that these points all lie right here, and to me that looks kind of like a line. It's pretty linear, and so I'm going to go ahead and say that yes, it does show linear function. So now how I can find that function? Well, I know the general equation of a line is y equals mx plus b, but I want to be specific. I want to be specific to this data. So this is in table 1, so after my y and my x, I type in a 1. So now it's just a little bit mad at me because it can't equal it exactly because it doesn't follow exactly a line. So instead of this equals sign, I do my little squiggly, which is right if you hit shift and then the key right above your tab key, you'll get that. So now here is my information. So you'll see I have my slope of 0.56, right, if I round this, and my y-intercept of a negative 2.26. So now I can go back and say that yes, this data shows a linear relationship. My y-intercept was at about a negative 2.25, and here is my slope. So I can go ahead and say that yep, this one works. Okay, so now I know that I've decided that was a linear relationship. So I can plug in when x equals 15, I just go ahead and I plug that into where x is here and kind of solve that. So I first come up with my y once I've done that, which means that after so many months, and I know that months was x, so I would say that after 15 months, the hair will be, and this is whatever I got over here, so long. And I know that because my y was in length, so I know that those go together. Okay, so here's something kind of similar. I would put this in Desmos as well. You can either use your graphing calculator or Desmos, but I tend to like Desmos because I don't always have my graphing calculator with me. So we're going to delete the points that we had before. But we can leave this second part because this we'll use again. So I just want to plug in the points that I see. So I see I have a point at 1, 2. I have a point at 1, 3. I have a point at 2, 3. I have a point at 2, 4. I have a point at 3, 4 and 3, 5, and then 4, 5. Okay. So now just looking and make sure I got all of my points. Again, this looks a lot like here. So again, I see I have my slope and my y-intercept, and I have this r value. Okay, and you see this correlation coefficient. That's my r value. So this tells me how strong, how close are my points to the line. Okay, so the closer to 1 this value is, the more closely my points lie on the line. Okay, and this also kind of tells me if it's positive correlation, so positive slope, or a negative, so if my slope is negative. So here I would say that this is a 0.88, so that's a pretty strong positive correlation that I see between those points. So we can go ahead and use Desmos anytime we see equation of line of best fit. We're going to see that with several families of functions. The biggest thing to remember is just that I don't use an equal sign. I use that squiggly, and then I have to specify my y's and my x's, and I can do that by just having a 1 with them. So now let's look at our next little things that we were struggling with. So here are some of these systems, okay, and I have 2 different examples because we can solve all systems the same way, but some are easier solved one way rather than the other. So again, my goal is to get rid of one of the variables. by adding the two equations together so I can find the other variable. Okay, so here I already see that I've got a positive 3y and a negative 3y. So if I add those two together, that kind of goes away. So now I have 4 plus 2 is 6x, and 2 plus 1 is 3. Well, so now I can just solve for x. I can divide by 6, so I know that x equals 1/2. Well, so now that I have my x equals 1/2, I can go ahead and plug that back into, to either of my equations, right? So I'd plug that back up in here and then solve for my y. So my x value will also go right here. So down with this next exercise, I still have a system, it's just written a little bit differently. So here I want to use substitution, and I know I want to use substitution because I already have a variable by itself and then equals. That just makes my life a little bit easier. So whenever I have substitution, I have something equals something. Well, now I see I also have an x up here. So anywhere above, I'm going to replace that x with what I have down below. So 4y minus 1 plus 2y equals 3. So I literally just took my top equation, and instead of x, I put this down here. So now I can distribute. So 2 times 4 is 8y minus 2 times 1 is 2 plus 2y equals 3. So then I've got 8y plus 2y, 10y minus 2 equals 3. Well, I want to add that 2 to both sides. So 10y equals 5. Divide by 10, because my whole goal is to get y by itself, so y equals 1/2. Now, just like we did above, once I find one of my variables, right, so my y is going to go right here. So now that I have that y, I can also go back into either one of my equations. I might use this bottom one, just seems easier to me, and plug this number in for y and then solve for my x. So then I will have both of my solutions. So try these all on your homework and see how you do.